And welcome to module number 8, which is about connecting networks. And briefly, we'll go through the knowledge check questions. So our first question is that what is the simplest way to connect to 100 VPCs together? So the best answer for that one is connect the VPCs to AWS Transit Gateway. The reason for that is the easiest and the cleanest way to connect to the large number of VPCs, like 100 in this case, is use of AWS Transit Gateway. Think of it as a central hub that simplifies your network connections. Instead of managing hundreds of individual VPCs, Peering Transit Gateway lets you connect to all VPCs, plug into one place, so traffic can flow securely and efficiently through the hub. It dramatically reduces the complexity and keeps your architecture scalable. Now let's go through rest of the other options that why we are not selecting connect each VPC to all the other VPCs by using the VPC peering is. The reason for that is that would mean creating 4,950 individual connections. For example, if we'll do a simple math of 100 into 99 divided by 2. So not only this is a nightmare to manage, it's not scalable and practical. The second option is to chain VPCs together by using VPC peering. This is also not the right option because chaining introduces routing limitations because VPC peering doesn't support transit routing. Traffic can't hop through the intermediate VPCs. And then we are not selecting the last option as create a hub and spoke network by using the AWS VPN Cloud Hub. The reason for that is VPN Cloud Hub is mainly for connecting on-premises sites over VPN, not for mass VPN to VPC connections inside a VPC. Now question number 2 says that a company needs network traffic to flow between the AWS account in one region to another account in a different region. What should they set up between the transit gateways in each region? So the right answer is transit gateway peering attachment. When you need to send traffic between transit gateways in different regions or accounts, you set up a transit gateway peering attachment. It is a direct AWS managed link that keeps traffic on the private AWS backbone instead of the public internet, which means that it's more secure and faster than a VPN. Now let's see the other options. Like we are not selecting AWS site-to-site VPN. The reason is that it would work, but it uses the public internet and adds latency and management overhead. We are not selecting direct connect. The reason is that it provides private connectivity to AWS, but not region-to-region transit gateway peering. And we are not selecting a private link over here because it's designed for private services access, not VPC to VPC routing. Question number 3 says that a company has 2 virtual private clouds. VPC A has the CIDR block of /16 and VPC B has a CIDR block of /16 as well, but both VPCs belong to the same AWS account. What's the simplest way to connect to the 2 VPCs so that they can route all traffic between them? Now just note that we have the IP address of 10.1 in our VPC A, whereas it's 10.2 on VPC B. So the right answer for this one is VPC peering. If you have got just 2 VPCs in the same account and they don't have overlapping CIDR blocks, VPC peering is the simplest way to connect to them. Once paired, they can route traffic between each other just like they were on the same network. No VPN or transit gateway is needed in that scenario. Now let's see that why we didn't select AWS Direct Connect. The reason is that for connecting on-premises AWS, not VPC to VPC. The second option is VPC endpoint is not a right option because it's used to connect privately to AWS service like S3 or DynamoDB, not over the VPC. And we are not selecting site-to-site VPN because it's an overkill for 2 VPCs in the same AWS account. Question number 4 says that systems in a secure subnet in a VPC must access bucket in Amazon S3. which solutions stop traffic from crossing the internet. So the first option is create a VPC gateway endpoint for Amazon S3, and the other one is VPC interface endpoints. Both of these options let your traffic stay inside the AWS network without ever touching the internet. A VPC gateway endpoint is used for S3 or DynamoDB, and an interface for the endpoint works for most of the AWS services through a private link. Together, they keep your data private and secure within the AWS internal backbone. Now, the wrong answers were, like if you read the first one, it says use the private IP address for Amazon S3. That's not right, because S3 is a regional service, not an instance with a private IP. We cannot select the second option where we say that use private IP address for the system. It means that it helps with the VPC but doesn't control how S3 is accessed. And then the third option, which creates the VPC peering connection to Amazon S3, is not the right option because S3 is not a VPC resource you can pair with. Question number 5 says a company has 3 VPCs. VPC A, B, and C have CIDR blocks that do not overlap. Both A and C have separate VPC peering connections with B. However, A cannot communicate with C. What is the simplest and the most cost-effective way to enable full communication between A and C? So the right answer is add a peering connection between A and C and route traffic between A and C through the peering connection. Since A and C already connect to B but can't talk to each other, the easiest fix is to create a direct peering connection between them. VPC peering is not transitive, so you must connect each pair that needs communication. Now, let's see why we are not selecting the first one, add route to B to enable traffic between A and B. The reason is that won't work because VPC peering does not support transitive routing, and we are not selecting the second option, which links all 3 VPCs together through a transitive VPC and route all traffic through the transit VPC. The reason is it's possible but adds complexity and cost for such small setup, and we are not selecting the third option, create VPC endpoints A and C for individual hosts that need to communicate with each other. Reason is that endpoints are for AWS services, not for inter-VPC communications. Question number 6 is, because of natural disaster, a company moved a secondary data center to the temporary facility with internet connectivity. It needs a secure communication or secure connection to the company's virtual private cloud that must be operational as soon as possible. The data center will move again in 2 weeks. Which option meets the requirements? So the only option is AWS site-to-site VPN. In a disaster situation, when you need a quicker temporary connection to AWS, a site-to-site VPN is perfect. It can be set up within minutes over the internet. It's secure and ideal for a short-term connectivity until a permanent solution like Direct Connect is ready. Now let's explore the other options of endpoint. It's not the right option because it's used to connect to the AWS services, not to a data center. We are not selecting Direct Connect as well. The reason is that it takes weeks to provision, not ideal for an urgent situation. And we are not going for VPC peering because for VPC to VPC, not for on-premises AWS. Question number 7 says that a company is concerned about internet disruptions. It wants to efficiently route traffic from their on-premise network to an AWS edge location close to their customer gateway device. What should they use? So in this situation, AWS Global Accelerator is the right option. AWS Global Accelerator routes traffic to the nearest AWS edge location for best performance and availability. It's built for scenarios where you want low latency, high reliability routing through the AWS global network, especially helpful when you are worried about the internet disruptions. Now, we are not selecting Direct Connect over here since it's a private link from on-premises to AWS, but not for optimizing global internet routing. We are not selecting the Transit Gateway. The reason is that it manages VPC connections, not traffic from edge locations. And we are not selecting VPN Cloud Hub. Reason is that it's used for connecting multiple VPN sites together, not for edge optimization. Question number 8 is, a company is implementing a system to back up on-premises system to AWS. Which network connectivity method provides a solution with the most consistent performance? So in that case, Direct Connect is the only option when you need consistent high performance network connectivity for data centers or backups. Direct Connect is the right choice. It creates dedicated private line between your on-premises infrastructure and AWS, reducing latency and eliminating the internet unpredictability. Now, if we'll see the first option, which is virtual private cloud endpoints, it's not the right option since only AWS services access it inside the VPC. We are not going for site-to-site VPN. It's cheaper but runs over the internet and can fluctuate in performance. And we are not going for private cloud VPC peering since for VPC to VPC, not for connecting on-premises systems. Question 9 states that a company uses a single AWS Direct Connect connection between their on-premises network and their VPC. They want to ensure that the network connectivity is highly available by adding a backup connection. Which network connectivity method provides the most cost-effective solution for the backup? So an on-demand AWS site-to-site VPN connection across the internet is the right option. For high availability with the Direct Connect, adding a backup VPN is the most cost-effective approach. You only pay for it when it is used and it activates automatically if Direct Connect fails, keeping the connection secure and reliable without extra monthly charges. Now, we are not selecting the first option as another AWS Direct Connect connection through the Direct Connect location. The reason is it provides redundancy, but it's expensive. The second option is that another AWS Direct Connection through the same Direct Connector location. Reason is still a single point of failure, and then an on-demand AWS client VPN connection across the internet is not the right option since that's for individual users, not for site-to-site networking or connectivity. Last question on module number 8 says that the company is connecting virtual private cloud to multiple on-premises data centers using a VPN. Which implementation ensures resiliency and predictable bandwidth requirement? So the right option in this case is to implement a Direct Connect as primary connection and use the VPN as the secondary failover connection from each data center. This hybrid setup is best of both worlds. Direct Connect gives you predictable bandwidth and performance, and VPN provides a secure backup over the internet if Direct Connect goes down. That's how you build resiliency and high availability for the multi-site connections. Now let's explore other options, like for implementing AWS Transit Gateway to connect to each on-premise data center is not the right option because Transit Gateways help manage VPCs, not on-premises links directly. Now, the other option was to establish multiple broader gateways session for each VPC to create connectivity to multiple VPCs across multiple AWS regions. That's complex and doesn't provide the redundant connectivity needed. And the last option is to use too many mesh topology such as Amazon VPC peering. It's unnecessary and hard to maintain for on-premise connections. So that was our module number 8. Quick knowledge check. That's it for today.